Hello and welcome to episode 6 of this tiny barn build series. Now in the last video we got the steel reinforcement in place and poured the concrete footing. And in this episode I'm going to be installing all of the timber shutter work, finalising and finishing off the rest of the reinforcement and pouring the concrete retaining wall. Well, that was the plan anyway. Whoa, 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 she's going! Hold it! Disaster! Now I've chosen to start on this side of the wall here and I'm going to be installing the formwork, but first I've got to remove, I think, this post. It's going to be in the way of my formwork. So I'm going to have a little go at trying to pry that post and its concrete footing out of the ground, and if that doesn't work I'll get the jackhammer and break up the concrete footing so I've got the space I need. But although this post was quite easy to dislodge, getting it out from behind the rebar, not so easy. It's really quite heavy. However, I didn't need the jackhammer, just hitting it a few times with the breaker bar did break up that concrete, proving that it really wasn't that strong, even though it had been doing the job of retaining this area for quite some years, in fact 2 decades. Well, now that post is out of the way, I've got 200 millimeters from the rebar to the rock face. The formwork is 100 mil, which gives me 90 mil cover if my wall starts at that point. So unless I want to do more digging, that rock's in the right place. I feel like just taking a bit off that, just to be safe. And that way I can guarantee that the rock isn't going to get in the way of the formwork when I'm trying to install it. Now I've been playing a dance for a while with this electrical supply pipe and the gas pipe here, and now is the time that they're really going to have to be relocated. They are in the way. Now I will be replacing these in the future, and so for now I just need to raise them up above the wall, and I think I've got enough slack in the pipe for me to be able to do that so that I can carry on but still maintain my gas supply. Now this is where my reluctance to get my feet wet in the concrete is going to bite me a little bit. Although this footing is level, it's not particularly flat and smooth, and there are a few little lumps and bumps in places, and I don't want to be putting my formwork onto those because then concrete could potentially run underneath if they're particularly bad. So I'm just going to spend 20 minutes an hour with this grinder just taking off those high spots. Small 4-inch angle grinder, and I've fitted it with a diamond disc that's got a flat base on it. So instead of using the edge of the disc, which is just going to dig in, I can use this flat surface, which is going to allow me to just polish off those high spots, hopefully quite quickly. Now the dust isn't particularly good for you, so I'm going to make sure I wear a mask and ear protection. Well, now that I've cleaned this footing up, I've put my string line back in place, pulled it nice and tight, and I'm going to use my level to plumb down from the string line to the footings and just make a few indication marks. And that way, when I put the formwork in place, I'm just going to butt it up to those marks and it'll help me get everything in exactly the right position. Now, this level is a little bit long, but it's the one I've got with me today, so it's the one I'm using. Now I'm pretty sure that professionals don't do this. They don't feel the need. But I'm not professional, and I've got the time, and I'm going to enjoy doing it precisely. So I'm taking my measurements from the 100 millimeter mark so that I know it's accurate. Measuring out to 350, so that's 250 wide retaining wall, and then strike a line through there. Alright, just pull this measurement again, and this from the outer edge of the tiny barn floor to the outer edge of the finished retaining wall should be 7.5 meters. So although I still have my indicator mark here, I just want to take the moment to double check it. So if I get my level in position, pull the tape measure from the other side of the barn structure and get that to 7.5 meters. Which is right there. Okay, now I'm going to attempt to knock a peg into this rock and pull a line through in between those two marks. Again, pulling that string line nice and tight, and then I can use the spirit level to plumb down onto the footings and mark out exactly where those formers need to be placed. And then it was just a case of marking out the chimney breast area. Now this is rather a complicated part of the wall. There's a lot going on here. There are two buttresses which are going to be supporting the retaining wall, giving it additional strength. And those buttresses are also going to be housing a special feature, which I'll talk about in a future video, and also giving support to the gas bottle enclosure and the chimney breast I'm building above. Now this structure is 2,150 wide, so if I measure from the centre line 1,075 in either direction, that way I know it's perfectly centred with the ridge of the roof, which is going to be above. Well, that's all the layout complete. Now to start building the forms. It would be easier to make new boxing to suit these runs and step heights from scratch. But I've got this second-hand boxing that I've bought off Marketplace, and so I'm going to modify that to suit. It's going to take me a little bit longer, but at least I'm recycling materials and it works out a whole lot cheaper. Here we go, the first of many pieces. Right, final brush to make sure there's no stones stuck underneath it. Now because I'll be stacking these on top of one another, whether it's level or not is not absolutely critical, especially on this side where I'll be cutting it to an angle. This wall has to slope on this side and it's level on the other two. But what is important is that that face there is plumb. If that's out of plumb, it could throw the wall that adjoins to it forward or backwards, neither of which is a good thing. So I'm going to get them mostly level, but then pay particular attention to the corner to make sure that they're plumb. Now I don't have room here on the footing to put bracing to support this boxing into position, and so I'm going to be bolting them down to the concrete footing. And I'm using these concrete screws in order to do that. They come with a masonry bit to drill the hole through the concrete, and the steel screw or bolt that has got the serrated finish. It's going to cut itself a thread into the concrete and just hold it down in place. You can see the sewer pipe here is going to be causing some issues with the wall. I can't just cast the concrete wall over and around this pipe, so I need to be able to create a gap or some clearance between the pipe and the wall itself. And to do that, I'm going to make up a plywood bridge or box, put that inside the shutter, and then once the concrete wall has been poured and I remove the boxing, I can remove this as well. And I've got this piece of plywood left over from the floor structure, and I'm just marking it out now to make up that simple bridge. And I want to try and make it so I can collapse the sides and easily withdraw it once the concrete wall has gone off. And bearing that in mind, screwing these three parts together isn't actually a great idea because they're bound together. And when they're inside the concrete, they're going to be stuck inside there. I need to be able to remove them individually. So I will later take these screws out. So that secures these two panels down to the concrete foundation. There's a mismatch in the alignment here. This one is actually tilting or leaning forwards, and that's okay. I've left the screws a little bit loose, so I've got this movement. I can bring them both to be flush with each other and then put a screw through the back, timber to timber. And to do that, I'm going to be using these bugle head batten screws, galvanized, 14 gauge, good diameter, so they're not going to snap under the pressure of all that concrete. That's good. Okay. I suppose I should check for level. It's actually perfect. Wow. Now in my bargain face market purchase of this boxing, I got a variety of widths. 300 wide, 400, 500, 6 and 650. And so I'm just going to take a measurement now as to where this wall, this pour of the wall, is going to end. Now the existing retaining wall is more or less exactly where I want the finished concrete pad to be. And the pad is going to be 150 mil or 6 inches thick. But at the edge around the perimeter, I'm going to make a beam which is 250 millimeters thick or 10 inches. And so if I get the level off the existing wall, more or less level, and take a measurement down to my boxing, the top of the wall is going to be around about 780 millimeters higher than the existing boxing. Now if I deduct my beam thickness of 250, I get 530, and so I need boxing which is 530 millimeters at this position here. Check they're in alignment with each other. I'm not too concerned about plumb at this stage. I just want them to be aligned. I'm going to plumb them up with some bracing afterwards. And that's actually leaning backwards slightly, but again, I'm not concerned just yet. Now I mentioned that all this formwork is actually recycled. It's second-hand, it's been used before, and so it's all the wrong size. So I'm taking some time here just to mark out what size I need for each of my runs and then making the modifications. Oftentimes that just means cutting through the plywood and relocating the timber framing which is on the back to give it its strength. It actually worked out very, very well. It may have been time consuming, but there was very little waste at the end, and that's got to be a good thing. Oh, that's nice. So I'm going to bolt these together first here and here. That gets them flush. I'm not quite on the mark because this is leaning forward, so then I can push it back, line up with the mark on the footing and bolt it through, holding it in place. Then it's just a case of wash and repeat, working my way around the footings, cutting the forms to size and installing them as I go. Now over on this side of the retaining wall, things are a little bit different and it's a bit more complicated. I can't just bolt the shutters directly to the footing like I can everywhere else because the floor structure for the barn is in the way. Now you might say, why didn't you just build the wall first? And that is a really good question. But not to worry, I have a plan. What I'm going to be doing is using some framing timber to make up the shutters in, let's say, 3, possibly 4 segments. Bolt those to the piles of this floor structure so that they can easily be removed in future, and then loosely attach the plywood skin. Now I say loosely, here's the issue. When the wall gets poured and the concrete is in the way, I can't take this shuttering away and pull it up past the floor. The floor is in the way. So I've got to deconstruct it in situ from underneath that floor in order to remove it. I think it's going to work, and if not, I've got a concrete and timber retaining wall in situ. But that's not going to happen. I'm going to be able to make this work. And the sun, of course, is getting pretty fierce right now, so I'm going to be a little bit sun smart. Pop the hat on. Built-in shade. Now the reason I'm plumbing down here from the edge of the floor structure to the concrete footing is because the finished concrete wall needs to be 100 millimeters away from this timber surface. And that will be more apparent when I actually build the timber structure, why I need that much space for the cladding system. But nevertheless, I need to know at this point 100 millimeters. So I've projected down and put a mark where the floor structure is, measure 100 millimeters away from that, and that's where the face of the plywood boxing needs to land. Now when it comes to bolting this in position, it needs to be perfectly spaced away from the edge of the structure, but also at the correct height, and it needs to be level. And I've only got one pair of hands. So I think the solution is to make up a bracket that can support it and hold it in exactly the right position. And so what I'm going to do is make myself a bracket, an L-shape or Z-shaped bracket that kind of looks a little bit like this. And the distance is going to be, it's going to set it 240 millimeters down from the underside of this. So that's going to be that height. It's got to allow it to project forward sufficiently. So I'm going to go for an 82 millimeter projection, and it just needs to come down the face here, let's say 100. So what we've got is a really simple bracket. I'll just make up a couple of those, screw them onto both ends of this, then I can just lift it up into position. Let's see if that works. Okay, let's get those together. Now let's see if this is actually going to work. So to help keep it in place, I'm just going to pop a screw in the center here, which I can take out afterwards. So this is the distance I need to be below this beam here, and this inside face needs to be flush or aligned with this face here. That means the boxing is going to be in exactly the right position. Now when the weight of the concrete goes in here, and of course it won't be much weight at this point because it's only this tall, but when the weight goes in, it wants to move this in that direction. And so these battens or braces are going to prevent that movement. I'm going to pull the plywood in and drop it straight down to the top of this step here, a couple of little tacks holding that in place, and then the weight of the concrete will ensure that nothing can move. So now those frames are all in place, and I'm confident that I can unscrew them after the concrete's been poured. I'm going to chop up these bits of plywood and just pin it to the face of those frames. I've taken some time to measure up what I need. I've got my plan here, and I've decided and worked out how they're going to fit on these sheets for maximum efficiency. And I think it's going to work out on just these two sheets. Now here's the reason I'm going to be so efficient with this. These two sheets cost nearly $200, and that's how much I paid for the entire pile of shuttering that you've seen me use, and I'm still only halfway through the pile. So it's expensive stuff. I don't want to make a mistake, and I don't want to buy a third sheet. And here's a top tip. If you need to make a cut starting in the middle of a sheet of plywood, you can actually plunge cut using a jigsaw. Make sure to hold onto the tool tightly and don't force the blade into the material, let the blade do the work. And as soon as it's pierced a hole, you can carry on with the cut as usual. Now for some reason when I poured this concrete footing, I didn't come back to this top section and flatten it off and level it off. And you can see that now when I put this piece of plywood in place, just how uneven this particular part is. So I'm using an offcut of plywood as a spacer to scribe the concrete onto the plywood, then I can trim it to the exact shape and give me a nice, tight, close fit. And to hold this plywood in place, I've purposely chosen a smooth shank, non-galvanized nail, because that way it won't have much holding power. Remember, I want to be able to remove these later. I'm down in the trench this morning for a nice early start behind the formwork, doing something that I should have done before I installed this plywood onto the formwork I built. And that is to cut the holes needed for 2 of these pipes. These are going to be carrying the conduits, which will be supplying things like water to the workshop later, electrical supply to the tiny barn, internet, and so on. And with that done, I can get on to strengthening up this formwork. I'm installing these strong backs of 100 by 50 or 4 by 2 all around the perimeter of the formwork. I do need to give some consideration to drainage behind this wall, and I'm going to be putting in a French drain with some pipe, but it's got to exit through the concrete pour. And rather than put the pipe in place now, I don't want to do that because I haven't dug the trench. I've made up this mould or this piece. Now it's slightly bigger at this end than this end. And the theory is that this sits inside the wall, the concrete gets poured all over it. When I demold the formwork and I hit it on this face, it's slightly tapered so it'll pop right out the other side. Now the likelihood of that happening is pretty slim. It's a big piece of wood, it's going to swell up. And so just to try and help me, what I'm going to do is cut a wedge through here. So it's now 2 pieces. And that way I can knock the wedge out, which should cause this top piece to drop and then easily be withdrawn from the wall. Now we won't know if this is going to work until we actually try and demold the forms. And if that doesn't make any sense, don't worry, you'll see it either work successfully or fail spectacularly. So to demonstrate how that might actually work, how I hope it's going to work, is that this will be completely encapsulated or surrounded by concrete, not at the front face or the back face. Now if I can hit this wedge here and just move it even a centimetre, 10 millimetres or so, that should free it up enough to be able to pop straight out because it's a taper. So if I can get that out, that should drop out quite easily. And although I've cut it into a wedge shape, I'm still concerned that the concrete will really grab hold of this. And so I'm going to put some cling film around that, wrap it all up, and that should help prevent the concrete sticking to it. Right, the final bit of insurance. There's a possibility that that could float in the concrete or at least shift. Don't want that to happen. I'm going to pop some screws in from the other side. That way I'll easily be able to remove them in the future. And with the inside skin of the formwork all complete, it's time to finish off the reinforcement. Now all of those vertical bars that are embedded into the footing of this retaining wall are now going to be braced against each other with horizontal bars at 200mm or 8-inch centres. I'm taking some time to make up these stirrups that are needed for the column because I need to slide them on as I'm positioning the horizontal rebar. Now it's important that these stirrups are exactly the right measurements. This was my first attempt. Now it should be 250 millimeters, 10 inches square. First problem, it's not square. Second problem is that we've got rather an odd shaped curve right here. Now it is important that when these are completed, not only are they square into the correct dimensions, it is also important that this angle is as shown here. Okay, it should come off the corner at 45 degrees. It should not return at 90 degrees like you would expect. And that's so that if there were some stress on the column and it were to spread apart, well, this will prevent it from doing that. That's not, of course, what it should look like. This is really what we're trying to achieve here. You can see that these two tails are longer than 10 times the diameter of the rebar, plenty long enough, and they're both at the correct angle. Let's see if I can replicate just a couple more, because I need 7 of these guys. Go. And these stirrups are going to be used to create a column within the concrete wall structure. The purpose of this column is to provide a connection for one of the posts supporting the roof structure above. And with that done, it's time to just put the final pieces of horizontal bar in place. Now I want to keep these as long as possible. The fewer joins, the stronger it's going to be. And it's quite difficult to bend, being the 500E grade, the strongest and highest tensile rebar available in this country. Perfect for an area that's so prone to earthquakes. So I've come to the realization that there are over 500 joins in this rebar structure. And that means I've got to make up 500 of these ties. Now what I've been doing, of course, is dragging this around the trench with me, along with the wire cutters, and making them in situ. And it's awkward with gloves on. So the sensible thing is to spend 10 minutes chopping this up, making up these wire bends, and then I only need to carry a box around with me. Sometimes it's the simplest things that can really save you. Well, this is just about the last piece of steel to put in place, and then I can clean up and start building the forms for the opposite side of the wall, for the front of the wall. But before I do that, there's a couple of other little things I need to take care of. And one of those is this box here over this pipe. I need to remove this box once the wall has gone off, and it's such a tight fit over this pipe, I'm not going to be able to remove it. And that's a concern. It cannot stay in there because it's resting directly on the sewer drain pipe. It's got to come out so there's an air gap or a space between the concrete and the pipe. So how do I get that out? Well, what I've decided to do is line it with some polystyrene. And that way, when the concrete's gone off, I can dig out behind the wall and push this wooden former out through the back. And it should be able to move because the polystyrene will give way, I think. And I've got this offcut of polystyrene underfloor insulation left over from the build of the subfloor structure, but it's much too thick to use, so instead I'm just ripping some strips from it to give me a 25 to 30 millimeter thick piece. So I removed those screws like I said I would. Ouch. And so the plywood's loose right now, but the wall itself will clamp down across here to hold it in position. Rebar is sharp. Now I'm hoping this tape will be just about strong enough if I double it back on itself like this to create a loop. If I put 3 pieces on to hold this down. It's just that initial impact from the concrete. I don't want it to move this polystyrene out of the way. Right, it's really bleeding now. Go. Nothing a bit of insulation tape can't solve. And then I can stick these bits of polystyrene down into position and, well, hopefully they'll remain in place once the concrete goes on. Then I can spend a minute or two just trimming down the length of these vertical pieces of rebar within the chimney breast feature, and the steel reinforcement work is all finished. We've got the column reinforcements, the chimney breast reinforcements, the short stem wall, and even the conduits for all the services, all in place and ready to get concreted. Now on this side of the wall, the top needs to be angled to match the slope of the existing car park space. And to do that, because I want to match what's already in existence, I'm just going to run a level and measure down 250 millimeters, and that is going to be the top of this pour of the retaining wall. And then when we come back and do the pad, that'll be another 250 on top of that. So I'm going to pull a string line from this point here all the way down to the end, and that will give me my slope, which we need to set the forms to. Now I've used these flathead nails. I don't know if you can see that there, but they've got a reasonably large diameter round flat head. What I don't want to happen is if I've got more concrete than I actually need, I'm going to raise the height of this wall very slightly, because remember, this isn't the finished height. And if I bury these nails in concrete and then the concrete goes off, that formwork is going to be mighty difficult to remove. So snipping the head off, I'm hoping that the formwork will pull away and the nails will pull away with it. And although I'll be able to feel these nails with my trowel as I glance over them, I'd rather be able to see them as we're pumping the concrete up and know when to stop. And so a quick spray paint ought to make them more visible when the pumping of the concrete goes on. And of course, because I use those brackets to set the level of these formers next to the tiny barn floor structure, the concrete just needs to come to the top of those formers. Now I've purposely not put the release agent onto the formers until I absolutely have to. And now I absolutely have to. This is the only opportunity to get access to that inside skin of formwork before I go and cover it up with the outside skin. Now this stuff has an open life of up to 7 days, so once it's sprayed on, the clock is really ticking. Now you do need to make sure that you don't get any of this onto the rebar, or if you do, wipe it clean, which would be impossible to do once the external skin of formwork is in place, so I'm making sure to spray these guys before I install them. And they're held in place the same way as before, using a masonry bit to drill into the concrete footing, and then a concrete screw to hold it in place. Nice. And yet again, the majority of these forms that I've purchased are the wrong size, but it's not that difficult to measure out what I need and chop them up into the right dimensions. So I've almost finished the formwork. I've just got these rather complicated side panels to put in here, which are going to support all of these various features for this chimney breast. I've got this back wall here, which needs supporting vertically. I've got this wall here, and of course I need to tie it in to this front here, and then cap off the front. This is going to be a buttress, both sides, that give additional support to the retaining wall, but also give me the structure that will become the chimney breast and something else, which I'll show you in a future video. Right, well, that's all the complicated bits done. You can see right the way down to the bottom of the trench there, where I've got the former for the storm drain, and the short stem wall here that's going to be part of the chimney breast feature. Now, calculating how much concrete volume I need to order to fill up this retaining wall is complicated a little bit by the fact that I have stepped foundations. So all I'm going to do is split this up into segments and sections, measure the length, the width, and the depth of each of those sections, calculate the volume, and add them all together. So for example, this section right here measures to the step 1.8 meters. It is 250 millimeters wide, so 0.25 meters, and depth, this is actually on a slope, so I'm going to go to the center and take the average. The average height of this section here is going to be 1.1 meters. So if I multiply 1.8 by 0.25 by 1.1, I'm going to get 0.495 meters cubed, a little under half a cubic meter for this section here. I'm going to work my way around the wall, taking all those measurements, add all those together, and that'll give me a grand total of how much concrete I need to order. Oh, that's wonderful. Thank you very much. I will see you on Thursday afternoon. Okay, that's the concrete booked and the pumping truck. That means I've got 3 days to finish off all of this formwork and get it braced and strong enough to support the tons and tons and tons of weight of that wet concrete. I'd better get my move on. And then, of course, on cue, it started to rain. And it's one thing to work in the rain, which I don't really mind, but it really doesn't do the tools any good, so got to keep those dry and under the floor structure for a bit of protection. Well, I did have to abandon play for the day. That rain really did get quite heavy. But the very next morning, it was perfect conditions to get out and put the final piece of formwork in position. And then finally putting the remainder of these strongbacks and bracing in place and hoping, just hoping, that these screws are going to be strong enough and long enough to hold back all the weight of that concrete. Why is the screw not going in? Let's try that on forward, shall we? That's much better. And just making some small adjustments to ensure that the walls are perfectly plumb as I attach them to the braces. Well, that's all the bracing in. Now I just need to check to make sure I'm actually ready for concrete. It's going to go around the entire structure and just give it the good old shake test. If there's any flex or movement, it needs more bracing. Like here, I've seen that this joint here isn't actually supported beyond the screws that are holding it together. And so I really pull on it. There's a tiny bit of deflection. Now, will the concrete push that forwards? I don't know. Let's not risk it. I'm going to take a piece of timber and just brace that back across like that. Screw in here, and that'll really strengthen up that joint. And now, absolutely no movement there. I've got one other place to do, and then I'm ready. Although I think I will be removing these safety caps before the pumping truck gets here. There's a good chance they get knocked off, and if they end up down in the trench, there's no getting them back. Well, after a final inspection, I've got to be honest, I think it looks like a row of condemned houses. But I'm pretty sure it's going to be a thing of beauty when I strip off the formwork. Well, it may not be the very best weather for concreting, but it's only fine rain. There's only the top surface going to be exposed, and when it's done, I'm going to cover it over with plastic. I don't want to delay the job. It's only a few days before Christmas, and if I don't do it now, it's not happening for a month. Now the whole idea about getting concrete pumped into position is that it takes all the stress out of the job. It gets it done more easily and certainly a lot faster. In theory, it couldn't be simpler. The guys pump the concrete into the void. All I need to do is make sure it's level, make sure it's vibrated to get rid of all the air pockets, but there are so many things that can go wrong or slow you down. Such as all this rain is turning the soil to mud. Makes it really difficult to navigate the job site safely. But the worst, the horror of horrors, is if you hear the formwork giving way. Whoa, 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 it's going! Hold it, hold it! Well, that's the pour finished. Is it an unmitigated disaster? Well, nearly. It's not a complete disaster, but it's certainly not a complete success either. Now, I've learned a lot in this experience about pouring retaining walls. Well, firstly, not to do it. I think concrete blocks are far more controllable. They're sort of easier, let's say. There's less risk of complete and utter disaster. Have a look at this. Well, having spent a few moments walking around the wall, just looking at the points of failure, it could have been a whole lot worse. We stopped at the right time. The wall that's going to have the brick skin on it has bowed most significantly. Now, it looks pretty bad. Take a look at these strongbacks, just how far they've moved at the base away from the wall. However, when I put a level across the wall, it really is only 30 to 40 millimeters of movement in the center. And it's not that the wall has bowed, it's that it's got thicker in the middle. So it's actually stronger than perhaps I would have designed it. And I can hide that with a brick skin, so it's not going to be a problem. Well, the other part of the formwork that bowed was around the column. And again, fortunately, it was the back side of the formwork and not the front that has moved. You won't see it in the final project, and so all of these mistakes are going to be hidden. Well, not a terribly successful day, really. I had hoped that the wall would be poured up to the finished level, that the formwork would have held up perfectly, that the rain would have stopped, and none of those things have happened. But that's okay, because it's not the end of the project, and it's not the end of the world. Ultimately, I do need to finish filling up these formers before I can remove them. I'm about 250 mil low here, running to about, I don't know, maybe 450 mil over in the center down there. So I will be mixing and pouring this by hand, certainly not while it's raining, to get this up to height, and then I can crack the formwork off and think, what next? You know what this really does though? It proves to me that concrete blocks are the way to go when building a retaining wall. One of the reasons I wanted to build this formwork was to try out the process, was to see just how easy or otherwise the project would be. And honestly, I think building the retaining wall up there with the brick skin out of concrete block was far more controlled. I felt like I could take my time with it. I felt like nothing could go wrong. Here, there's a lot that can go wrong. The benefit, the plus, of course, is that this happens really quickly. Once you've built the formwork, it's just a case of half an hour's work and the job is done, but only if it goes well. But when I consider the amount of time, energy, and potentially money to build all of these forms, then I don't think it was worth it in the end. This is good. The workshop, when I get round to building that, it was going to be a retaining wall of either concrete block or formwork with poured concrete. And I think this has made the decision for me. Anyway, I'm going to wrap up this video now. It's just a couple of days before Christmas. What, you really didn't think I'd leave it like that, did you? Let's get mixing. So I'm using a ratio of 3 to 1. It's 3 parts aggregate and sand to 1 part cement. And the reason I'm doing that is a standard mix of 5 to 1 gives you a 17.5 MPa strength of concrete. Standard strength. I need super strength for this. I'm going for an intermediate 25 MPa, and that means a ratio 3 to 1.
'Twas the night before Christmas, when all through the house not a creature was stirring, except the sound of Dan Waterson unwrapping the biggest present.
Well, now the formwork is off, I can take a look at really just what the situation is with this side of the wall. Now, all the movement in the formwork happened on the back side of the wall, the side that you never see. That's a good thing, except, of course, here, where the back is laser straight, of course, and the front is the one that's bowed. It's not the end of the world. As I mentioned, there's going to be a skin of brickwork in front of this, and I can hide any unevenness in this wall. But the question is, how uneven is this wall? Now at the front here, I can see that to give or take 3 mil, we're actually dead straight. And of course, the wall in the corner didn't move, or the formwork didn't. Back here, this is where things move the most. If I take a level, I can see that the wall has bowed in the center 40 millimeters, so a little under 2 inches. Now that's not a massive amount to bring my brickwork forward to hide. The good news, what that means is this wall is in the order of 340 millimeters thick. That's nearly 4 inches thicker than I designed it. I think I can say that that's a successful fail. Just to remove the final few pieces of formwork and I can tidy up and get ready for the next phase of the build. Well, after a little bit of drama and a healthy dose of panic, I think this wall turned out really quite well. And a great way to start the new year. I wish you a very happy new year. Thanks so much for watching. I'll see you in the next episode. Bye.